I'd like to present a little bit of different things. So today we attempted to identify SARS-CoV-2 peptides by LC-MS. So this work was done by this phenomenal team here of these 5 people who, during the COVID crisis, really spent weeks and weeks and nights in the lab to optimize these methods. So I'm greatly thankful for Akshada, Ataka, and Francis, Andrew, and Tian. As you might know, we are in a pandemic, and we were funded by the UK Department of Health to test if we can actually detect COVID-19 and screen COVID-19 by LC-MS. The point for this was particularly because the idea was that you could multiplex it with other respiratory viruses such as flu A and B. And our aim was clear to say the turnaround time has to be within 2 hours, and it should not take more than 5 minutes per sample. Now, this is our sample. I have to move some windows here, sorry. This is our sample prep here. When we received both saliva samples and swab samples from the NHS, and I can tell you straight away, this is not something you want to work with. Some of the swab samples we had were virtually big boogies, massive amounts of snot, and some of the saliva samples we could see remainders of what looked like food. And this is obviously not something for a proteomics lab to, we are not used to have these kind of samples. So we came up with a really interesting sample prep method, particularly also because the sample were often already inactivated in 70% ethanol, which is obviously also not ideal for any form of proteomics work. So once we had the samples, we added actually 5% STS to try to denature and recover everything was in there, because we feared that some of the proteins may be precipitating in 70% ethanol. We then put them onto the so-called S-traps. So S-traps are some cleanup columns which are from a small company called Protify in America, and they're actually really cool because you can put every sample buffer you want really onto these samples, and then your proteins will bind to these S-traps, and you can actually get rid of all the nasty buffers that are in there. So even 5% STS isn't a problem. And then you do on the S-trap, you do a wash, and then you actually digest straight on the column. And you do this within like 45 minutes to an hour at 47 degrees. And this works really very, very well. And once you elute your samples, there is actually 3 steps that you elute with, but we realized the last step, which includes acetonitrile, wasn't really necessary to get the most of the peptides down. So this meant we could actually elute in TAB and formic acid and then go straight into the mass spectrometer, which made the whole process actually possible to do it within 1.5 hours, which we felt was really powerful, considering that we were asked to do this in a very short time. We then did LC-MS on an Evosep 1, either with a 200 or 300 samples a day method, and then analyzed this on a Q-Exactive HF. Our data analysis was done in Skyline. We also compared this setup, as I explained to you here on the left, which is about a 5 minutes per run sample turnover, together with a system that Thermo Fisher really wanted to get tested for clinical use. And this uses a Vanquish Duo HPLC system and an Exploris 120, which we could use in PRM mode. This system works such that you have 2 pumps and you get about 3.6 minutes per run. However, as you can see in the columns, it's a 2.1 millimeter column. So you run this at analytical flow, which is obviously having considerably other problems within sensitivity. So how do we detect SARS-CoV-2? So we use PRM. So for the people who may not be used to this, so once you have peptides digested, you can now use your quadrupole in these Orbitrap type instruments to select specific peptides, and then the fragmented peptides are then detected in the HCD cell or in the Orbitrap, and the intensities of these fragments are now being used to quantify your peptide. And we got actually really nice quantitation for that. So we also used an QCon cut, so heavy labeled peptides that allowed us to do absolute quantitation of these peptides. And as you may know, obviously everybody speaks always about the spike protein in viruses, but actually the spike protein is obviously important because it's on the surface of the virus, and this is where the antibody binds. But actually NCAP, the nuclear cap protein in the virus, is actually about 10 to 20 times more abundant, and this was the one that actually worked out much better. So we did dilution series, and you can see here from 44 femtomoles to about 20 attomoles on column, we do see peptides. But as you can, what you can see, and what is obviously becoming a later problem, is that you start losing some of the transitions, and in the end, you actually at the lower intensities, you only see one of the transitions. And this is obviously something that then means you're not selective enough anymore, even if you have very high mass accuracy on these type of these instruments. So overall, we had about an LOD and LOQ of about 80 to 100 attomoles on column. But the moment we put obviously the samples in some form of sputum, in this case it was an artificial sputum, we got about 10 times less sensitivity, and we actually assume that, you know, even if you go into even more complex matrices like real saliva and these snot samples, that you probably even get less sensitivity. And there's also, I mean, I think we're still in the low femtomole range on these, and it's actually very very linear responses that we got for these peptides. Now, when we did this on the Evosep 1, here on the top you see the retention time stability for 300 injections of samples in saliva, and I think the retention time is absolutely amazing how it's brought on. At the bottom you see the signal stability for a number of peptides and what happens after 250 samples. It was not the Evosep that was the problem, it was actually the emitter, because as I said, some of these samples are really rather dirty, and although obviously we had quite some cleanup and so on, our emitter gave up, although I have to admit the emitter had been on for already quite a few hundred samples, so I don't blame anyone really for that. When we compare this to the Vanquish on the Explorer 120, just quickly, the way this works is you have two pumps and two columns at the same time. So while one column is running the analytical flow, the other one is actually washing and reconditioning. We do feel it's quite powerful, but we do see instantly that the sensitivity on this system, because you have the high flow rate, is not competitive compared to the Evosep system, because as you remember, we were like in the attomolar range on these peptides, and now we are in the femtomolar range. So I would say it's about 10 to 20-fold lower sensitivity, and this is particularly, I think, because of the high flow rate of the system. While the retention time here was also very nice and the signal stability was very nice on the system, what we do see is because of the high flow, you actually have to clean your mass spectrometer pretty much every day because of, well, literally the crap that ends up on the mass spec. As you can see here, this is after 300 injections. And this was not something we had to see when we did, obviously, the low flow on an Evosep system. Now, one of the problems when you do these kind of assays where you want to have a positive or a negative is you need to have actually some form of a control that your samples work, because if you don't see anything, how do you know it actually is a negative? So we realized the best protein to have as a digestion control is actually lysozyme, which is very abundant both in swabs and in saliva. And here you can see, while there is obviously between individual samples quite a bit of difference, overall it works quite well. And again, the sensitivity, the retention time is excellent for all of these peptides. Now, then when we started looking at some of these clinical samples, we did see some peaks, but then we started realizing that we had some as you can see, so this is now for intensities for a specific peptide that we saw, but actually our QC samples were always about half a minute earlier. And this is where we started realizing that actually, because of the complexity of the matrix, we do get some false positives. And this is something that other people had seen as well. So we very much had to start looking very closely into the transition order of individual peptides in order to see, is it actually a true positive or not? And obviously the other thing that really made a big difference is if we scheduled only a 2.5 minutes and not a 3 minutes, obviously we got rid of these false positive hits here. Now, did it work? Well, I must say, I always thought it was a challenging thing. It does work. So we had actually a few patients that we knew were positive and we detected. So here on the top, you see the transitions for the Q-con cut, and here at the bottom, you see the patient. And so this is a clear positive, and it's in a very nice spectrum for it. But however, this person had a CT value of 17.8. So I'm not sure if you're aware of the qPCR method. So I've been involved a lot since the beginning of the pandemic in supporting the NHS with this. And obviously, if you do qPCR, anything that has a CT value under 20, it virtually means it's full of RNA. It virtually has, these patients obviously had virus coming out of their ears virtually. And it was really a bit sad that we did see patients that we could identify as positive, but again, most of them were really at very, very low CT values, which means they have incredibly high numbers of viruses. So I do feel, while this method really worked, from an analytical standpoint, I think really nicely, because we don't have the ability to amplify our system as the people do in qPCR, I don't think we will be able to compete with them unless there's some form of enrichment step, which actually now people work on. They use antibodies to enrich the virus in the sample. Now, to conclude this, I must say swab and saliva samples are probably the most difficult biological matrices I have worked with in my career, and it is something you have to be aware if you ever plan to do some samples like that. As I said, in some of the samples we virtually had massive boogies, and this was really not particularly easy to handle. How do you pipette something that is full of snot? We can detect actually viral particles and proteins down to really low femtomole range on both instruments, and the setups in both ways are actually really robust. We didn't have to do any column changes, although the difficult and dirty matrix. We do feel the Evosep setup is clearly more sensitive and should be considered, I think, over the analytical flow approaches, which are currently favored in the clinical environment because of its robustness, but I think the sensitivity really makes a big difference. And obviously, what is very important also is that you have high retention time stability and high resolution on the mass spectrometry, so it can actually help you avoiding false positives. So I wouldn't want to do this on a triple quad type instrument, because I don't think you won't have the resolution in order to identify false positives. So I think this was a start, and although it wasn't possibly as successful as we had hoped, we think it is actually an interesting tool to use these kind of LC-MS approaches in clinical use. And we are now working with the clinical labs here in Newcastle for that. And we think in the future there may be ways of using these assays in the clinic. So that's my end. I'd like to thank you for your attention, and again, I would like to thank my amazing lab for working on this. Thank you.